We've already talked about elements which contain one kind of atom and compounds which contain more than one kind of atom bound in a particular arrangement. We're going to introduce an umbrella term for those: pure substances. Pure substance is a material that contains just one kind of molecule. On the right here, you can see a sample of O2, which contains just O2 molecules. It's an element because it contains only one kind of atom, and it's a pure substance because it contains one kind of molecule. Further to the right here, you have a sample of NO, nitrogen monoxide. It's a compound because it contains more than one kind of atom bound in a specific arrangement. The specific arrangement is that there's one nitrogen bound to one oxygen in every single one of the molecules of this stuff. It's also a pure substance because it contains a single kind of molecule. Now, a mixture is an impure substance. It contains more than one pure substance. You can also say that a mixture contains more than one kind of molecule. Now, you can mix the substances in any proportion that you like, and we say that the mixtures have then variable composition, while a pure substance has fixed composition. What do I mean by that? A pure substance like this compound will have a fixed percentage of nitrogen by weight. Since you can mix the nitrogen and the oxygen in a mixture in any proportion, it won't have a fixed percentage of nitrogen by weight. So that's what we mean by variable composition in a mixture versus fixed composition in a pure substance. Now, there are two types of mixtures. There's homogeneous or homogeneous mixtures, I should say, that are evenly mixed. They're mixed so well that they seem to be a single substance. So if you take one little chunk, a drop of this solution, it's the same as every other drop. So we can say that the composition is uniform throughout. It's the same throughout. But you can have, again, any composition you like. Now think about coffee and sugar. Some people like lots of sugar in their coffee. Some people like only a little. In either case, once all the sugar is dissolved and evenly mixed, you have a solution or a homogeneous mixture. The composition, the concentration of the sugar can vary from coffee cup to coffee cup. A heterogeneous or heterogeneous mixture is unevenly mixed. It contains distinct chunks with different compositions. So this chunk up here is O2 and this chunk down here is N2. They're made of different stuff. We say they have different composition. We call this chunk a phase. A phase is a region with a particular composition. Composition changes abruptly when you cross from one phase to another. Now that's the essential difference between a homogeneous mixture and a heterogeneous mixture. A homogeneous mixture is a single phase, one phase, no boundaries. And the heterogeneous mixture has multiple phases, and it's got phase boundaries. So in a heterogeneous mixture, you see these phase boundaries between the phases. And in a homogeneous mixture, you don't. What's an example of this? Oil and vinegar salad dressing is a classical example of a heterogeneous mixture, and you can clearly see the phase boundaries between the oil droplets and the vinegar. Now, you can mix the heterogeneous mixture up so fine that it is tough to tell whether you've got a homogeneous mixture or a heterogeneous mixture. A finer grained heterogeneous mixture would be mayonnaise, which also contains tiny droplets of oil in a watery liquid. The watery liquid's usually lemon juice or vinegar with egg yolks. You'd need a microscope to see the phase boundaries because the oil droplets are so tiny in mayonnaise, but they're there. The egg yolks contain a protein that spreads along the phase boundaries of the oil droplets and it stabilizes them. So the little oil droplets don't coalesce and separate out again like an oil and vinegar mixture will. So without microscopic examination, how can you really tell a homogeneous mixture from a heterogeneous mixture in everyday life? We'll see the answer to that in the next slide. Before we leave this slide, though, I want to point out how these things are spelled. There's a little E there that comes after the N in homogeneous and heterogeneous that you have to put in. That's kind of important when you're typing this in as an answer to questions in the homework. If you spell it wrong, the homework won't necessarily recognize your answer. So learn to spell these two words correctly.